Okay, we are on our 5th day of mole unit or chemical quantities. Basically, we're converting all kinds of things in this unit. Usually using dimensional analysis. We're going to take a break from dimensional analysis, and we're actually going to learn how to calculate percent composition by mass. So basically, we're going to be given a molecule and a mass, and we're going to have to figure out how much percent mass one atom is out of that molecule. So the goal is for us to be able to calculate what I just said. So percent composition is just basically the mass of the element divided by the mass of the compound times 100. So let's do our first example. So what is the percent lithium in lithium oxide? So we have lithium oxide, and it wants to know the percent lithium. Okay, so what we're going to do is we must first find out how much the molecule weighs in general. Let me get my periodic table. So we have lithium, and we have 2 atoms of it, and we have oxygen, but we only have 1 atom of it. So lithium is here, and it weighs 6.94. And oxygen is 15.999. So we're going to find out how much each of the atoms contribute, and then we will calculate it and add it. First we turn our little computer on. 2 times 6.94, 13.88. So 13.88. Then we don't really have to calculate that. Even I can do this without messing it up. Okay, so lithium will weigh this much, and then oxygen weighs this much, and we're going to add it, and we'll know how much lithium oxide weighs. So 13.88 plus 15.999, 22. And since I only have 2 significant figures here, we're going to go ahead and follow our rules. So it's 29.88. Why did I put 22? .88. Okay. So since lithium weighs this much, and the actual molecule weighs this much, all we're going to do is take lithium and divide it by the whole molecule's mass. So basically the percent of lithium will equal 13.88 divided by the mass of the molecule, which is 29.88. That's weird. And then we're going to multiply it by 100. So $13.88 divided by 29.88 equals, we're going to multiply that by 100. Or you could have just moved the decimal over. And the answer will be 46. We're going to use significant figures. There's 4 and 4. So 46.45%. So the percent composition of lithium is 46.45%. Okay, let's do the next one. The question is, what is the percent of each element in barium arsenate? You will know what that is called later when we learn how nomenclature, how to name these molecules. But right now, you'll just have to take my word for it. That's barium arsenate. So barium arsenate. Okay. All right. So basically, first we need to write out how I like to solve this. Is I write out how much of each, I like to write out which atoms I am dealing with first. So first, I have barium. I have arsenic. Arsenic, yep. I get arsenic and arsenicose mixed up. Arsenic and oxygen. That's it. So barium, I only have 3 atoms of barium. Arsenic, I have 1, but in parentheses, it represents that I have 2 of whatever's in here. So I have actually 2 arsenic, however you want to say it. And then I have oxygen, which I have 4 of them, but because I have this 2 on the outside, I have 8. Okay, so now I just find out how much each of them weigh, and then multiply, and then add, and then divide, and then multiply, and we're done. So barium, 137.33. Okay, arsenic, 74.922. And oxygen, 15.999. Okay, so now we just multiply 137.33. I feel like we've done this one. 2 times 74.922. All right, now we're going to add all 3 together. Comes out to be 689 point. We kind of got to stop after 2 points after the decimal. So we're going to say 0.83. Okay, so it's not just asking for one, it's actually asking for each element. What is the percent composition for each element? So now what we did just in the last problem, we have to do it 3 times. So we need to find the percent of barium. We need to find the percent of arsenic, and the percent oxygen. So again, how we do that is we take the mass of the actual atom, divide by the mass of the molecule, which is this. So they're all going to be divided by the mass of the molecule, which is 689.83. Okay, and then we just take each of their respective masses, which this one is 411.99. Arsenic is 149.844. And oxygen is 127.992. And then of course we need to multiply by 100. That's 1. And then we will have our answers. Okay, So for barium, I don't know if there's a glare. Okay, for barium, 411.99 divided by 689.83 times 100, or you could have moved that decimal over. 59 point, so we have 1, 2, 3, 4, 5, so, and 5, so 5 significant figures. So 1, 2, 3, 4, 5, so 723%. Here there's 6 and 5, so 5. 149. I was looking at significant figures, I'm sorry, I was kind of thinking out loud. Divided by 689.83. We're going to multiply, no, that was wrong. I did something wrong, let me just start over. 149.884. Divided by 689. There we go, that looks better. I don't know what I did. You could move the decimal over 2 or multiply by 100, whatever you're comfortable with. 21 point, and we need 5 significant figures. It looks like it'll be 5 because they're all, this is the lowest one. So 21.722, because that 8 made that one rounded 2%. So barium, this is the percent for barium, this is a percent for arsenic, and then we just need to find out the percent for oxygen and we'll be done. So 127.992 divided by 689.83 equals, we could just scoot the decimal over to the right, or we can multiply by 100. 18 point, and we need to stop it at 5 significant figures. 1 won't round the 4 up, so it's going to be 554%. So what that means is that 59.723 of this molecule is from barium's mass, okay? And then 21.722% of this molecule's mass is arsenic. 18.554% of this molecule's mass is oxygen. So that's basically what we've learned to do today, is calculate these percent compositions.